Here's some raw data for a potential political candidate. So what data structure do you think we should use in Elixir to hold this information? Well, this is basically a set of key value pairs, so using a map, which is essentially a key value collection, would seem to be a natural choice. So for example, you could create a candidate variable, and then you could bind it to a new map that includes a name field, which is set to Will Ferrell, an age field that's set to some integer, and you could add a party field and set it to an atom named Democrat. Now, let me add one more bit of detail about this data structure. For discussion's sake, let's say that these three fields are the only fields we intend on using for political candidates, and each of these three fields should have non-nil values. So if we're going to use an Elixir map to store the candidate information, can we in any way guarantee the map will always have these three fields and nothing else? Well, no, not really. With maps, you can add as many fields as you want. You could have one field, you could have three fields, you could have 100 fields. So as you can probably tell, maps aren't going to help us control the fields used for a candidate data structure. However, there is a different data structure that's very similar to maps, which we can use to ensure only these three fields are used on a candidate record. The data structure I'm referring to is called a struct. So how do you create a struct? Well, let me show you. First, you have to create a module that contains the struct. Okay, what do I mean by module? Well, you've seen several modules already, such as the list module, and the map module, and the IO module, just to name a few that we've seen and used so far. Generally speaking, you should think of a module as a way to group related things, and by related things, I largely mean functions. For example, the map module has a bunch of functions, which you can see here, that can be used to transform maps. But modules do more than just group-related functions, and one of the other things modules do is act as a container for defining structs. Okay, so how do you create a module? Well, first you'll create a module by keying def module, followed by a meaningful name for your module. We'll call it candidate with a capital C, then we'll enter the do keyword, which marks the start of the module definition. Now to define a struct in this candidate module, I'll key def struct, then we'll add a list of fields that this struct should contain, which in our case will be the following list of atoms: name, age, and party. The last thing we'll do is add the end keyword, which closes out the definition of our module. Now I'll press enter and check out what gets printed in the terminal. So what do you think this is right here? Well, it's not super important that you totally understand what this is, but I think it's helpful to have a sense of what just happened and, generally speaking, what this is. So let's start by taking a closer look at this keyword here named a def module. Odds are, if I didn't point out exactly what this right here is, you'd probably just think it's a language keyword, which is sort of true, but there's more to this than meets the eye. So any thoughts on how to find out more information on this keyword named def module? How about using our helper function? Okay, well, there's a lot of documentation for this, but for now, let's just scroll to the top and just focus on the first part of the docs. This documentation kind of looks like function documentation. It's almost as if def module is a function that takes a couple of parameters, but notice a couple of terms you see here and here, macro. So it turns out def module is actually something called a macro, which is a term you're going to hear me start using more and more throughout this course. Now, you're probably wondering, what exactly is a macro, and aren't we supposed to be talking about structs? Yeah, we're going to get back to structs in a moment here, but I want to continue on this slight tangent for a moment. This thing called a macro is used extensively in Elixir. In fact, most of the language features you'll be using when you write Elixir are actually just macros. Now, we're not going to do a deep dive into macros in this course. That's a topic for a more advanced course. However, I believe it's helpful to have a basic understanding of what macros are, even if you never author or create macros. why do I think you should know about macros? Well, for one thing, you're going to start seeing the term macro and hearing about macros, so naturally you'll be curious. But even more importantly, understanding what they are will give you a better sense of how Elixir works. Okay, we're not going to dive further into macros at this point, but I want to give you a way to think about macros as a beginner. For now, you can think of macros as functions similar to other functions you've used so far, but here's one of the major differences between macros and regular old functions. Functions typically take data as parameters and potentially transforms the data and returns some data. Macros are different in that they don't take data as parameters, they take code as parameters, and it transforms the code into other code. In other words, it's code that receives code and transforms and returns a new code. Now, this description isn't 100% accurate. There's more to the story, but it's a good way to start thinking about macros for now. Macros probably seem kind of cool, right? And they are, but for now, try not to get distracted by macros. I just want you to be aware of the term macros, and later in the course, we'll take a closer look at macros. All right, let's circle back to structs, and in particular, what we see in IEX after we created the candidate module. So what do you think this is? Well, the truth is you don't need to know exactly what it is, but here's what you should understand. This bit of code here got transformed into other code and eventually compiled into something called bytecode, which is an intermediate language that the Beam virtual machine can run. Okay, so we created a module named candidate, and we defined a struct for this candidate module, but now the question is, how do we actually use it? In other words, how do we actually create a candidate struct to contain the actual candidate information? Well, you do it almost identically to how you'd create a map. So to show you, I'll create a variable named candidate, and I'll bind it to a new candidate struct, which you can construct by keying a %sign and a set of curly braces, similar to how you'd create a map, but between the %sign and the opening curly brace, you'll specify the struct's name, which is the module name, candidate. Then inside the curly braces, we'll add the three fields name, which I'll set to be Will Ferrell, age, which I'll set to be 52, and party, which I'll set to be the Atom Democrat. Do you think I need to specify all three fields when creating a struct, like I did here? In other words, could I leave off one or two of these fields? Let's try and create another candidate struct, but this time I'll just add the name, which I'll set to be Kristen Wiig, and I'll just key in a closing curly brace and press enter. Well, that seemed to work. The other two fields, age and party, are part of the struct, but their values were just defaulted to nil. What do you think will happen if I try and add a field to the candidate struct that isn't one of the three fields we defined? For example, what do you think will happen if I add an active field and I set it to be true? Well, let's see. Well, it didn't work. It gave us an error. But here's the nice thing about this type of error. This error will be generated at compile time rather than runtime. So if we accidentally try and add a non-valid field to a struct, the compiler will identify this mistake and we'll be able to fix it. Let's use the iHelper to take a closer look at our struct. So I'll key I, then I'll pass in the variable candidate. Okay, well, the data type is defined as a candidate type, which, as you can see in the description, is a struct. Now, one of the big differences between a struct and a map is that structs have a special struct key or field, which you can see here, whose value is just the identifier candidate. Now, notice the reference modules for the candidate struct are the candidate module, which we created a moment ago, and the map module. There's a couple of things to take away from this line. First, the map module and all its functions can be used with structs, which is really nice. Also, this module, the candidate module, might be a good place to put any functions that are specifically meant for the candidate struct. Keep that in mind for later. Now I want to draw your attention to the implemented protocols right here. I'm not sure if you remember, but maps had more implemented protocols than what you see here. In particular, maps had the collectible and enumerable protocols, which structs don't have. You should be aware of this because it means there are some things you can do out of the box with maps that you can't do with structs. We'll touch more on this a bit later in the course. I want to look at one more thing. I want to create a new candidate struct, but I'll only provide the name. Now in this case, which is similar to what you saw earlier, the age and party fields defaulted to nil. But what if you'd rather not have these two fields default to nil, and instead you'd rather they defaulted to some other value? Well, this is possible, and the way you do this is by changing how you define the struct. Earlier, when we defined the candidate struct, we just passed in the list of atoms. However, if we'd like to specify default values for the struct fields, we can change the list from just a list of atoms to essentially a keyword list, where the key represents the struct field name, and the value becomes the default value for this struct field if you don't specify a value when you're creating this struct. So for example, if we want to redefine what the candidate struct should be, we can just key def module, candidate do, and then I'll key def struct, but this time I'll pass in a keyword list. I'll set the name's default value to be an empty string, the age I'll have default to 0, and the party will have a default atom of none. Oh, one more thing. You remember how keyword lists had a special, more terse syntax when it was the last argument to a function? In other words, you could drop the square brackets. Well, you can do the same thing when defining structs. You can drop the square brackets so long as the list is a keyword list. Okay, I've got more exercises for you to practice creating structs. You'll see the exercise instructions after this video. Okay, we've covered most of the highly used Elixir data types, and as I've mentioned several times, all data in Elixir is immutable. In other words, it can't be changed. I want to take a closer look at immutable data, and that's what we'll do in the next video.